So before we look into the formula, I want to ask you guys a simple question. What if we don't have a unit mass or a charge? See, the point what I'm trying to make over here is, if I want to find the potential difference between A and B, right? In case of gravity, I need 1 kg mass. If I want to find the electrical potential difference between A and B, I need 1 coulomb of charge. But what if we don't have this 1 kg, if not 1 coulomb? No, we might have 100 coulomb, we might have q coulomb, we don't know. So in place of 1, we might have m kg mass and q coulomb of charge. So how can we make use of this, and how can we find the potential difference? So let's take this case. Let's take a variable which is not 1. So let me take 5 coulomb of charge. Okay, this is your negative charge. Let me not take it as positive. Let's take it as negative. So I say I lift it from point A to B. And I happen to do a work of, say, 40 joule. Right? Now, how will I find how much work I will do on a single coulomb of charge? I have to use the proportionality concept. P-R-O-P-O-T-I-O-N-A, proportionality concept. So what does it tell? If I have a mass, right? Not mass, sorry, in this case, charge of 5 coulomb, and if I happen to work 40 joules of work, but in place of this, if I had a single coulomb of charge, how much work will I do? So I can cross multiply and find that answer. This is what proportionality tells. So x is equal to 40 into 1 by 5. So this is the fundamental idea. So basically your answer over here is how much? 8 joule of work we need to do, on per unit coulomb of charge. So basically this is the funda. But in place of 5 coulomb, what if I had q coulomb of charge? And in place of 40 joule, what if I had spent w joules of work? So all we can do is replace it. So instead of 5, I'll write q. In place of 40, I'll write w. So your x will be equal to q into 1 divided by w. Right? I hope. No, sorry. It's the other way around. W into 1 divided by q. So w by q. Make sense? This is your formula for potential difference between point A and B. So potential difference, electrical potential difference to be specific, is nothing but work that is done on any coulomb of charge. Say in this case q coulomb of charge divided by that coulomb of charge, that value of charge. Okay, so work done on work, let me write it pura, work, let me write it clear, work done on q coulomb of charge entire thing divided by the value of q coulomb. That's your electrical potential difference formula. Symbolically, we represent it with a slanted V being equal to W representing work and Q representing the charge, Q coulomb of charge. Okay, so this is your formula. So I guess you guys can write this down. It will help you guys understand the concept and help you guys remember the formula as well.